Welcome to Go Engineers Shape Your World session on flow simulation. Today's session is going to look at the Disco Inferno BattleBot, and we're going to run two different flow analyses on our robot. The first is going to be the temperature and heat generated from the motors inside of the BattleBot. We're going to create our flow simulation using the wizard. First step of the wizard is to give the study a name. And then the next step is to set the units. We want to use the USA units, but we want to customize them a little bit. So we'll go down into the heat units. And we want to change the total heat and power from BTU to watts. If we want to use these units over and over, we can create a new system, giving it a name. That will now put it in the list of units available when we run the wizard again. The next step is to choose the analysis type. We need an external analysis with heat conduction turned on. We will choose our default fluid, which will be air. So we'll go into the gases library and we'll pick air. Because we are running a full thermal analysis with conduction, the next step is to define the solid material. And for the solid material, we're going to use aluminum 6061 for everything. This menu would be used for defining the airflow. In this case, we just have natural convection, so we don't have any velocity in the X, Y, or Z direction. The next thing we're going to do, now that the study is created, is modify the computational domain. So we'll just right-click on computational domain, and we'll set edit. We can either type in values for the X, Y, and Z min and max, or we can just use the drag handles to size the computational domain the way we want it. For the first run of the analysis, we want to have a small computational domain. That way it solves quickly and we can make adjustments to the study as we need it. The next step is to create our heat sources. We have two motors inside of the BattleBot, so we're going to need two different heat sources. When we're adding heat sources, we have the option of a surface heat source or a volume heat source. In this case, we're going to use a volume heat source, and we want to apply it to the motor. So we'll use the flyout tree to be able to go into and pick the motor. It is generating 5 watts of heat. We'll add our second heat source using the flyout tree, and we're going to go in and pick our motor there, and it's also going to generate 5 watts of heat. The next step of our project is to create the goals. Goals are items that we want measured during the analysis. We're going to set a global goal measuring the maximum temperature that the structure sees within the analysis. Once we have all of the goals set that we want, we're ready to run the study. While the solver is running, we can create a preview plot to watch the analysis as it develops. So we're going to use the XY plane, and we want to monitor temperature. Once the project has completed running, we can start to look at some of the different results. The two main results that we're going to use in a thermal analysis is a cut plot and a surface plot. All we have to do is right-click on cut plots, and we have to move the plane where we want it. So we're going to put it right in the middle of that motor, and we want to see temperature of everything. We're going to create another cut plot. We're going to adjust it to where it cuts through the other motor, looking at temperature. So this gives us a good visualization of what the temperature distribution looks like and the heating of the air in and around our BattleBot. The other plot that we're going to look at is a surface plot, and we want to measure the surface temperature of our two motors. So we'll pick those, and we want the temperature of the solid. So now we can see the temperature that the motors get to. We also created a goal measuring the temperature, so we can take a look at that. And the temperature within the entire BattleBot is 158 degrees. The next analysis we're going to run is a flamethrower. We're going to start by running the wizard. And we're going to use that new custom unit that we created. So we'll find our USA with watts. It will be an external analysis with heat conduction in solids. And this time we need it to be time dependent because we want to see how the flame develops and dissipates. So we'll run the analysis for 10 seconds and we're going to take results every 0.1 second. Our default fluid is going to be air again, and our default alloy is going to be 6061 aluminum again. It's still going to be natural convection, so we are not going to define a velocity in the X, Y, or Z direction. We're going to adjust the computational domain. So we use the drag handles to set the size that we want. To simulate the flamethrower, we're going to use a boundary condition. It's going to be an inlet velocity. And we want to define that velocity in a time curve. We also need to define the corresponding temperature curve. So we'll go into the thermodynamic parameters, and we're going to build the time-dependent curve for the temperature. When the flamethrower is off, it'll be at room temperature. When it's on, it'll be at 1,000 degrees. And then we're ready to run the project. Once the solver is completed, we can create our first cut plot. We're going to create our cut plot through the flamethrower. So just make sure that the plane is lined up, and we're going to look at the temperature. Because this is a time-dependent study, we look at one step at a time. This is at 10 seconds, so the end of the analysis. If we want to look at a different time step, we just right-click on the results and load a different time moment. We'll pick a time step that's right in the middle of the flamethrower, so 1.5 seconds. And we can see that 1,000-degree flamethrower on the robot. If we want to look at all the time steps together, we can create an animation. So we'll go to that cut plot, and we want to create an animation. To create the animation, we want to run the wizard to load the results. So we need to delete all the existing tracks. We need to run the scenario, which is all the time steps put together. And we want it to run from start to finish. Next step is to choose the plot we want and create the step. And then we'll have it run the animation. So we can see how the flamethrower develops the flame and then how it dissipates. Then we'll just save that animation to use later. We've looked at two different flow analyses on Disco Inferno. The first was how the motors heat up the entire robot and the air surrounding it. And the other was to simulate a flamethrower. Thank you for joining this session on flow simulation.